right, so this is a shout out to Sydney and anybody else? Addie? I don't know anybody else who's gone the other hours, but we miss you guys. We hope you're doing well. Do we know where they are? Ireland. She's in Ireland. They don't get the internet over there, so she can't watch the videos. How about Sid? Do we know where she is? Iowa State University. All right. You know the best thing to come out of Iowa, don't you? Interstate 35. All right, there's my joke. My YouTube ratings will just go drop after that. I've got a large viewership from Iowa, so. All right. Okay, so when you get done with pre-calculus, you should be able to look at anything and graph it. For example, if I gave this function to you, y equals log base 2 of x, do you know what that looks like on a graph? You probably don't remember, do you? But we did it. We did it. And so if you saw the graph again, it would probably come back to you a little bit. Well, it's even more important with your trig functions, especially sine and cosine. And we're going to graph sine, cosine, tangent, cotangent, secant, cosecant, and it looks daunting at first. But you're going to be really good at it and really efficient. So much so that this will probably be the #1 thing that you remember for when you take calculus next year. One of the #1 things you remember from trigonometry is solving triangles and graphing sine and cosine. And if that's it, I'm very happy. Okay, I'm very pleased that you would remember that. Okay, so yes, we do, just not today. No, graphing tangent is easier, but you don't really understand why tangent works out the way it does until we do sine and cosine. Sine and cosine are really the foundation for graphing all the rest of the trig functions. If you could graph these two, you're good to go. If you can't graph these two, you probably can't do any of the rest. So that's just the way it is. All right, I gave you guys a few sheets. Look at this sheet right here on your back. Okay, I gave you a new unit circle basic sheet. Hope you like it. I made the necessary changes. There was a couple mistakes. And then if you flip that sheet over, I have for you all the parent functions for the graphs. And so we're going to do sine and cosine today. Okay? You get both of these on the test. This last page, you can use this whole thing on the test. Okay? So, let's go to this sheet right here, okay? And I want you to look at the unit circle. Remember, sine is opposite over hypotenuse, otherwise known as your y value divided by your r value. Now, if you're in the unit circle, what's your r value? 1. So if you look down here, it says sine is opposite over hypotenuse, or y over r. If r is 1, then sine ends up just being your y value. So as you look at these coordinates all the way around the unit circle, sine is just the y value. So what's the sine of 0? It's whatever the y value is at 0. What's the y coordinate at 0? Look at your sheet. What's the y coordinate at 0 on your unit circle? It's not 1, it's 0. What's the y coordinate at pi over 6? 1/2. What's the y coordinate at pi over 4? Root of 2 over 2, which is like 0.7071. What's the y coordinate for pi over 3? Which is 0.866. And what is the y value for pi over 2? 1. What do you notice about those values if you continue around the unit circle? They kind of repeat themselves, don't they? Sine is positive in which quadrants? First and second. Negative in the third and the fourth. So all we're going to do is we're going to unravel the unit circle for the y values, and it will take shape in the graph of sine. Let's do it. What is the largest value? We're going to look over the interval of 0 to 2 pi. What's the largest value that sine can have in the unit circle? 1. What's the smallest value that sine can have in the unit circle? negative 1. If you go all the way down to the bottom, the y value is negative 1. Okay? So the maximum value that sine has, and this is the parent function, okay? Basic graph or parent functions. The minimum value is negative 1. We'll do the amplitude and the period in a second, okay? 0 and 2 pi, interval notation. So it includes 0 and 2 pi. Okay, so once around the circle is 2 pi. How many quadrants are there? 4. So I divide it up into 4 parts. So this will be the sine values or the y values in the first quadrant. This will be the y values in the second quadrant, the third, and the fourth quadrants. See how I have them all represented? You guys told me sine was positive in which quadrants? First quadrant and second quadrant. So it's negative in which quadrants? It's negative in the third, negative in the fourth. All right, let's go back to what we just talked about and get a graph. Sine is the y values around the unit circle. When you start at 0, what is the y value at 0? 0. What was the y value at pi over 2? 1. This is the most important part of today, that you guys see this unraveling process. If I look at pi over 2, the top of the unit circle, you can see that the y value is 1. When I go to pi over on the left-hand side, what's the y value? When I go to 3 pi over 2, or the bottom, what's the y value? And when you move back up to 2 pi, what's the y value? 0. If I connect the shape, what shape do you have? It's a wave. Can you travel more than once around the circle? And if you travel more than once, it will just continue to repeat itself. Can you go the opposite direction around the circle? Like negative pi or negative pi over 2? Yeah, and that would be the left side of the graph. So this is the parent function for y equals sine of x. For all sine functions, this is where we start. Now there's two things we need to define here. Amplitude. What is amplitude? Yeah, it's kind of how big the wave is. How much it moves up or down from the center. So if the center is right here, how high did it move up? 1. The period is how often it takes to repeat itself. And this repeats itself every, not every pi, but every 2 pi. It does come back to those values, but they happen to be negative. So we get the positive values to pi, and then we get the negative values to 2 pi. And then it will repeat itself to positive and negative. What do you think? X doesn't change the graph, but A and B will. So what we actually did here is we did these things. We did y equals the sine of, and we plugged in 0. And the sine of 0 was 0. And then we did y equals the sine of pi over 2. And the sine of pi over 2 was 1. Those were the y values on our unit circle. Cosine. Is cosine going to be the x values or the y values? X values. X values. Same thing. We'll look from 0 to 2 pi. We're still going to have a maximum of 1 and a minimum of -1. Cosine is very similar to sine. I'm going to divide it up into 4 parts. Why 4 parts? Because there's 4 quadrants. And let's see what we get. Let's start right here. Okay. We're going to go around the unit circle again. Okay, so we got to think through this. Cosine is going to be the x values. Cosine is the x values. So cosine of 0 is the same as the x value on the unit circle at 0. What's the x value on the unit circle at 0? 1. Does everybody see how we got 1? Whoa. Go away. Don't want you. Try this one. There we go. Okay, here's how we got 1. If I look at 0 on the unit circle, it has a coordinate, 1, 0. The x value is 1, the y value is 0. So we're looking for these coordinates, and that's what cosine will assume. It will assume the x values. So it starts at 1, and then it goes to, -1, and around that way. So cosine is the x values. So let's plot that. So again, the cosine of 0 was 1. What's the x value at pi over 2? 0. What's the x value at pi? -1. The x value at 3 pi over 2. And the x value at 2 pi. Alright, let's see if I can do this. What shape do you get? It's another wave. Similar to the sine one, isn't it? Yeah. This is my favorite part. You guys can't do it because you don't have a smartphone. Watch. I take my graph, and I'll take the cosine graph, and I'll move it up here. Okay, so there it is. They look similar, don't they? All it is if I shift it over, they're the same graph. They're just shifted. That's it. Shifted pi over 2 units. What do you think, Sine? It's great. All right. So there you go. So I can put it back to where it was. So you can see how closely they're related. So what's the amplitude for cosine? Still 1, and the period is 2 pi. So their characteristics are very, very similar. Like I said, all the differences is that they're shifted. Okay. All right, so those are your parent functions. We don't want to just deal with the parent functions. We want to deal with the transformations. Don't write this down, but this is what we're going to do. We are going to graph y equals a sine of bx minus c plus d. Or say y equals -2 sine of 4x minus pi over 2 plus 3. You want to be able to do that by the end of tomorrow. And you'll be able to. You'll do it very well. You'll be very good at it. However, it looks kind of complicated right now. And I get it. It does look complicated. Instead of dealing with all the C and D stuff, right now all we're going to deal with is the A and B part. Okay? So we're just going to look at A and B. Now, if I gave you this, you don't have to write this down either, y equals 4x squared, and y equals x squared, how are those graphs different? One stretched. This is stretched vertically by a factor of 4. So if you put a number in front of the graph sine of x, it's going to vertically stretch it as well. So that's going to change the amplitude. The amplitude is the absolute value of a. Same thing with cosine. Cosine, the amplitude is the absolute value of a. Now, this b on the inside, does that affect the graph horizontally or vertically? Horizontally, and so that affects the period. So your period ends up being 2 pi, and we divide it by b. And that's the same case for both of them. We'll talk about the steps for graphing sine and cosine later on. Right now, we're going to try a few examples here to see if we can get it. These notes I give to you guys right on that sheet. So that sheet I gave you right here, at the bottom, you can see the amplitude and the period are all right there. So let's flip it over. Let's go to work. The first thing you're going to have to do, we're going to go example 2. We're going to skip example 1. I don't have that ready to go for you guys. We don't need it. We'll go example 2. First thing you're going to have to do on your test is identify amplitude and period for these type of functions. So what I do is I just write down A and P. A and P. What is the amplitude for letter A? 2. For the period, I take 2 pi and I divide it by 3. So my period's 2 pi over 3. That's it. You like that? What's the amplitude for the next one? 3. Always the absolute value, so it's always positive. Sometimes people write down negative. I got to take points off if you do that on a test. I don't like to do that because I want those to be easy points. Now remember, the period is 2 pi divided by b, but what is your b value in this problem? b is not 4, but 1/4. Very good. So you take 2 pi and you divide by 1/4. Dividing by 1/4 is the same as multiplying by 4, so I get 8 pi. So you can see that stretched it horizontally, didn't it? Instead of repeating itself every 2 pi, it's now repeating itself every 8 pi. So it takes a lot longer to actually repeat itself. What's the amplitude for C? 1. So take the absolute value of -1, which is 1. And the period will be 2 pi divided by 2 pi over 5. Now, what does that look like? What do I do? 2 pi over 1 times 5 over 2 pi. What happens? They cancel. I get 5. Yes. So your period doesn't have to have a pi attached to it. Doesn't work like that. Okay, don't have to have that. We got y equals -1/4 sine of pi x. Amplitude? Very good, 1/4. Period? Take 2 pi and divide it by pi, and I get 2. Those will be the first questions on your test. Got an A so far? All right. How about you, Holly? You got an A? All right. Got it? All right. All right, let's try something else. Describe the relationship between the graphs of f and g. Consider the period and the amplitude. I have 2 graphs here, f of x and g of x. They're similar, but they do have differences. And we'll look at the amplitude and the period for each one, and we'll try to talk about how they'll look different. What is the amplitude for the first one? 1. And the period? 2 pi. That's just your parent function. Amplitude for G? 1, period, pi. So the amplitudes are the same. How would you describe the difference then? Don't just say the period is different. What does that look like as a graph? Very good. If the period is pi, it will repeat itself twice by the time this one repeats itself once, right? This one takes 2 pi to repeat. This one only takes pi. So G repeats twice as often. You could also say it's a horizontal compression by a factor of 2. However you wanted to say it, that's up to you. Okay, what else is different about the graph? What do you notice? It's a negative. Well, if you saw y equals x squared and you saw y equals negative x squared, how would you say those are different? Reflection over the x-axis, vertical reflection. So same thing. You got a negative in front, sine is reflected vertically over the x-axis. So you got G is reflected over x-axis. Very good. How about those two? What's the amplitude? 1, period, 2 pi over 3. Got that one. Amplitude is 4, period. So these have the same period, so their horizontal part is the same, right? I mean, they repeat at the same spot. So how would you describe the difference between the amplitudes without simply saying the amplitude is 1, the amplitude is 4? G is stretched vertically by a factor of 4. Very good. What else is different? Very good. G is reflected over x-axis. All right, we didn't have time to get through the last problem today during class, but we did get through the first 3. So your assignment will be what we're going to do now. You have all of it now running up in your brain. It's time to put it to practice. Let's do it. When you do your assignment, identify the amplitude, identify the period, and then put the graph on there just like we did right away at the beginning. What's the amplitude? 1. What's the period? 2 pi. So I mark those. Amplitude up 1, down 1. Period, 2 pi. Divide it into 4 parts for the 4 quadrants. Those are the first 2 steps. The third step is to actually start to put the dots down. Now, did sine start up at 1 or did it start at the center? It started at 0, okay? And then it went up to 1 right away, right? But it's going to go down to -1. Why? Because the negative reflects it over the x-axis. So instead of going up to 1, we go down to -1. And once you have that motion, then the rest is easy. You don't even have to think about it after that. The pattern just continues. I went from 0 down to -1. Where do you think I go after that? Yep. Now I go up to 0. And after that I go to up to 1. So now I'm at my top spot. If I'm at my top spot, now I have to come back down. So I go to 0. And that just continues on and on. As soon as you figure out the direction of your dots, from your first one, then you just follow the pattern that we already laid out. That's your graph. So we just showed one period. The assignment may say to show 2 periods. Don't worry, just show 1 period and you're fine. Yeah. Okay, up 1. Well, I'm sorry, what am I doing? Okay, what's the amplitude? Amplitude is 3, period. 2 pi. So go up 3, go down 3. Take 2 pi and divide it into 4 parts. This is a cosine graph. How is a cosine graph different from the sine graph? It started up at 1. So this one's going to start up at 3. Where does it go? Down to 0. Then -3. Then 0. Then +3. Very good. I think we'll get the last 2 in. Very efficient. What's the amplitude for that one? 4. What's period? 2. Guess to just mark them. Hello, hello, hello. Get done with the assignment? I'll be bored tomorrow. Well, what did I put 3 pi over 2. I'm not thinking. Not thinking clearly. Anna walks in and all I think about is pole vault. Alright. Okay, there we go. There's our numbers. Where does this one start? Starts at 0. And where do I go first? I go up. Why do I go? Last time I went down. It was reflected. Now it's not reflected, so I just continue to go up. Go up to 4. Then 0. How are your graphs coming? Are they pretty? Your homework is right there. So we did 3 graphs at the end of class in about 5 minutes. All I have for you for homework is 7 graphs. No matter what the directions say, do exactly what we did at the end, and you should be just fine, good to go. Okay? Sure. Well, I didn't run off packets yet. I'll do that, I promise. But that's it, boys and girls. A+ for all y'all. Oh, sure. Yeah, great. Super. Just this one. But I'll take them both and I'll change your grade. Thank you.